hard question. So firstly, thank you to all the organisers for inviting me, putting on such a great show. This has been brilliant so far. And thank you also to Antonio for kind of setting things up really nicely for the kind of things I'm going to talk about. So I think everything he said about my paper was exactly right, and I like the application to geodesic motion in GR. I'm going to make quite a similar application of basically the same framework in this talk, but to emergent spacetime in quantum gravity. So the question now is about how spacetime depends on a non-spatiotemporal fundamental level. What sort of dependence is that? That's what I'm going to be talking about. And I'm going to be using the same sort of framework that Antonio described, but I'm not going to be using exactly the same terminology, because although I like the terminology of like big C causation as the genus level notion and then the different species of causation and grounding, that was almost kind of deliberately controversial when I put it in that paper to kind of get people riled up. And I found that to kind of have maximal appeal, I've dropped that terminology. I'm just going to be talking about causation and grounding here, but really I haven't actually changed the view at all. That I still think there's a kind of unified underlying notion here. It's purely a terminological difference from the picture that Antonio was describing. Okay, so here's what I'm going to be doing. First of all, spell out those two different varieties of dependence. And maybe it's a massive simplification to think there's only two varieties. There's only two broad varieties I'm going to talk about. No doubt they have kind of subcategories anyway. But for now, I just want to kind of sort things out between those two categories. And then I'm going to talk about the kinds of things you might do to distinguish between causation and grounding, or in the old terms, between metaphysical causation and nomological causation, how you might go about doing that. So Antonio didn't talk about this, but in the abstract, he distinguished them via a temporal ordering as opposed to a kind of ordering of fundamentality of levels. And that's an extremely well-known, common, popular way to distinguish grounding and causation, I think. It's kind of the standard way. But it's not actually a way that I think works ultimately. And so I'm going to set out that way of distinguishing grounding and causation, which I call the temporal diagnostic test. And first of all, point out that it doesn't apply straightforwardly to the emergence of spacetime in quantum gravity anyway, but then if you kind of modify it in a reasonably obvious way so it would apply there, there are still some problems with temporal diagnostic tests more generally that mean we should look elsewhere for a kind of a way of drawing a distinction between grounding and causation. And that's something that did come up in Antonio's talk, the approach of distinguishing via the principles that mediate a connection. So these mediating principles as either being laws of nature on the one hand for causation, or metaphysical principles, or constitutive principles, as I'll often say today, on the other for grounding. So the idea is that we have some kind of pre-theoretic grasp on what the difference between laws of nature, dynamical laws of nature, and constitutive principles is, and we can use that to help us understand the different kinds of dependencies involved. So I like that diagnostic test. I think it gets nice results in a lot of straightforward, familiar cases. But you might think of this as just a counterexample to the test, or you might think of it as kind of a challenge, kind of worthy of further investigation. When you apply that test to emergent spacetime in quantum gravity, I'll use loop quantum gravity just as a toy case, but really the technical details of quantum gravity are not something I'm going to be delving into in any detail at all in this talk. The result seems to come out that the emergence of spacetime in quantum gravity is causal. So the fundamental underlying reality is causing there to be spacetime, or causing spacetime to exist. And that feels a peculiar result. It feels counterintuitive, I think, to a lot of people. So I'll look at some ways you might try to avoid that result. And there are some ways which I quite like, but are wildly controversial within metaphysics. So I'll just kind of point at them, and we can come back to those. But what I'll explore primarily as a kind of way of getting out of that conclusion, is to endorse the kind of space-time functionalism that Eleanor defended yesterday so ably as an account of what space-time is, the kind of thing that can be multiply realized in different underlying fundamental theories. Space-time might be something different at the underlying level if we have a Newtonian theory than space-time is in a theory of emergent space-time like quantum gravity. So different things can fill the functional role of space-time in different theories. And I think that avoids, at least for the immediate moment, the conclusion that space-time emergence is causal, which is a good result. We want to avoid that. It does potentially just kind of push the problem one stage further down. And I'm going to argue that unless you change something in your kind of underlying metaphysical assumptions, unless you kind of do metaphysics differently from the way most metaphysicians do metaphysics, there's going to have to be a causal stage somewhere along the line during the emergence of space-time. It may not be space-time itself is directly caused, but it may be that space-time is grounded in something which in turn is itself caused, or is grounded in something which is itself caused, or so on. There has to be some causation somewhere along the line. And I think that's still surprising. But at least we've pushed the problem a little way away. And the picture I'm going to defend is something very like the hybrid picture that Antonio ended up defending in the context of GR, a kind of hybrid view, whereas the emergence of space-time is the result of some causation and some grounding kind of collaborating to give you emergent space-time. So there's a role for causation and a role for grounding in the overall story. Kind of ecumenical picture. That suits this place. Okay, so what is emergence? It's gigantic literature. Karen told us a little bit about it yesterday. And I'm not going to go into the kind of the huge complicated literature in emergence in any detail. I'm just going to offer this kind of really, really simple schematic analysis. There's like kind of at least two elements to an emergence claim. One is dependence. So the emergent thing depends on the thing from which it emerges. And the other is a distinctness claim. The emergent thing is in some respect distinct from the thing from which it emerges. And where you have dependence of the right kind and distinctness of the right kind, then you're going to get emergence. That's the broad schematic claim here. And if you don't like that simple analysis, then just kind of pretend I'm not using the word emergence at all. I'm just talking about dependence. Forget emergence. And the nice thing about this kind of simple analysis is that you can kind of separate out controversies about the dependence from controversies about the distinctness. So one of the big debates about emergence is to whether to go for a weak or a strong version, as Karen was describing, and that can be roughly kind of aligned with different kind of distinctness. So weak emergence is where there is some kind of epistemic barrier to going from the underlying level to the emergent level. Whereas strong emergence, there's something more than merely epistemic, an epistemic barrier. There's some kind of ontological difference, and that's the kind of thing that people tend to have in mind when they say there's something kind of really genuinely new or novel or like metaphysically or ontologically autonomous at the emergent level. But for our purposes, I just want to ignore all of those controversies and say there's some kind of distinctness involved. I'll stay neutral on what that distinctness is and focus entirely on the dependence part of the story. What kind of dependence is involved in the emergence of space-time in quantum gravity? That's the main question. And as won't surprise you, after sitting through the last talk, the way I want to do that is by looking at a kind of general analysis of dependence and sorting out the causal dependence from the grounding dependence. So again, in the circumstances, we don't need much setup, but we've got some paradigm cases here of causation, some paradigm cases of grounding. And actually think the temperature case is, having written this talk, I then decided maybe the temperature case is not as entirely straightforward as I thought it was, but it's the kind of thing that people think about when they talk about grounding in physics. The way in which the temperature of a gas depends on the kind of collective motion of the molecules that make it up. But you also get grounding in cases like set theories is a classic example in metaphysics of singleton Socrates and Socrates inside it. And then the case, like in the football example, of some kind of set of rules. And it doesn't have to be rules of football, it can be like moral rules or legal rules. And the thought is that the legal and the moral rules can ensure that some underlying fact about what happens, like that some event is a killing, is responsible for the fact that that event is morally wrong or is illegal or something like that. So I hope we have a kind of a broad enough understanding of the difference here, and hopefully the distinction is clear enough, and your intuitions about the emergence of space-time are kind of orthodox enough that you're inclined to put emergence of space-time in quantum gravity into the grounding bracket. I think most people's initial intuitions are that this isn't causation. For whatever reason, whatever kind of intuitive conception of causation people have, it's much more like these cases of grounding than it is like these cases of causation. And I'm going to argue it's actually quite hard to get that result from a well-motivated account of the distinction between grounding and causation. And that if we want to get that result, we might have to tweak some metaphysical presuppositions or move to some sort of functionalist picture of space-time. So the thing that most people say when I ask them what the difference between grounding and causation is that it's to do with time. So the most natural way of putting this is that causation is a dependence relation that goes across time. I'm going to say it's diachronic. So kind of an event at one time or a fact about one time causes an event at a later time, a fact about that later time. And it's kind of something in the nature of causation that it takes you from one time to another time. Maybe if you can have backwards causation, you can take causation from a later time to an earlier time, but it's still from one time to another. Grounding is not meant to be like that. Grounding is meant to be kind of synchronic. It's kind of, at any given instant, there's dependency between how things are at the fundamental level to how things are at the next level up, which in turn grounds how things are at the next level up. But that's all dependence relations that hold at a single instant. And it's kind of an intuitively appealing way of distinguishing grounding and causation. It gets some of the really basic cases right. It gets most of these right. We naturally think that the later motion of solid objects is caused by their kind of incoming motion when they collide. When you add a chemical, then it causes a chemical reaction that kind of starts and goes on at a later time. And then if you behave unhealthily, you get a disease later. That all fits the diachronic model. Likewise, I think these cases of grounding all fit the synchronic model. It's like the motion of the molecules at a given moment that fixes the temperature of a gas at that moment, and so on. Maybe the sets and their members case is a bit more complicated because we might think that these things are outside time. We'll see that's going to be a problem that arises in the emergent space-time case. So when we do try to apply this simple synchronic versus diachronic test to emergent space-time, we immediately run into a hiccup, because the kind of fundamental non-spatiotemporal reality is non-spatiotemporal. It doesn't exist at any particular time. It just exists. And likewise, it's kind of strange to say that space-time, that the emergent kind of space-time itself exists at some time. It kind of constitutes time. It doesn't exist at a time. It is time. It's not in time. So the kind of dependence involved doesn't seem to be either diachronic across times or synchronic at some time. You might say it's achronic. It's non-temporal in its nature. So does the temporal diagnostic test just break down in that case? I actually think this is a decent argument against it. But there is kind of an obvious way to patch it up, which is instead of distinguishing diachronic from synchronic, just distinguish diachronic from non-diachronic. So now causation is dependence that goes from one time to another, and all other dependence just kind of gets put into a basket containing everything else. So you're either causation or you're not, and if you're not, then you count as grounding. That's the kind of picture envisaged by this modified temporal test. So it has a few odd consequences here and there. So I'll just highlight one in kind of philosophy of religion context. Maybe we don't care about having weird consequences in philosophy of religion, but I expect a lot of metaphysicians will care about this at least. It's natural to think that if you have a deity that's creating the universe, and that deity is kind of creating the universe and creating space and time along with the universe, that's a natural way for somebody kind of theologically inclined who also believes in modern space-time theory to think about the creation of reality by a god. It's very familiar to think of God creating the universe as a causal process. So God is causing the universe to exist. But given the modified temporal test, that's going to come out as grounding. Because if God is outside of time, then God's creation isn't at some earlier time, so it's going to count as grounding. So God can't cause, an atemporal God can't cause anything. Can't create the world, and they can't intervene in the world either. Again, maybe your response is who cares? But just to kind of point to that consequence, what moves me more is what seemed to me to be a family of counterexamples in both directions to the temporal test. So these are counterexamples to the modified temporal test, but they're also counterexamples to the original version of the temporal test. They seem to just get the wrong results in these cases. So one natural class of counterexamples involves things that we take to be causation, but still synchronic. So you see why that's going to mess up both of these tests. Both of them say that causation is diachronic dependence. And a very familiar example from elementary physics, Newtonian physics, is F equals ma. It's very natural to think that forces cause accelerations in Newtonian mechanics. It's kind of one of the first things we teach kind of primary school children about forces and accelerations. But it doesn't seem to square with the temporal diagnostic test, because the force is imposed at the very same time that the acceleration is caused. So that looks like a kind of counterexample. And other cases of simultaneous causation of any kind you like might well seem to fit this, and come up with your own favourite case of simultaneous causation. I'll note that a kind of divine intervention kind of model or divine creation might also be a counterexample of this kind. But there's also, I think, counterexamples in the other direction, cases where you have dependence that's intuitively grounding but is diachronic. I think, Antonio, you kind of dismissed the possibility of such cases, but I think they're worth considering. One kind of really, you might think just a cheesy case is when you add the prefix X to something, so or former to something. So Obama is former president of the USA, unfortunately, and what makes it the case that he is now a former president is that back then he was the president. That seems to be like his past presidency is responsible for his current former presidency. That looks like a case of grounding across times. There are some peculiar theories in metaphysics that's like ways of defending presentism that say present facts are grounded in facts about what happened. Maybe that's, if you translate that in a certain way, that comes out as diachronic grounding. Maybe like suppose I'm the 50 billionth human ever to exist. The fact that I'm the 50 billionth human ever to exist kind of depends on all the other 49 billion ... humans that have existed before me. So again, maybe that's some kind of diachronic grounding. You can try to come up with more such notions, such examples if you like, and we can talk about them in the Q&A if you want. But I'm not here going to kind of stick rigidly to those counterexamples. That's not really my focus. I just want to use these to kind of give us some motivation to look elsewhere, because I think there is a nice account of distinction between grounding and causation which doesn't bring in time at all, and which is thereby nicely suited to the kinds of cases like emergent spacetime that don't seem to naturally be treated in this temporal way. So that's what I'm calling the mediation diagnostic test. And again, Antonio kind of sketched this earlier. I have this notion of mediation, which is a relation between a certain kind of principle and the dependence relations that in fact hold in reality. So where you have a dependence relation, those dependence relations usually or always seem to be kind of instances of some more general pattern. You know, the throwing of the stone caused the breaking of the window because events like the throwing of the stone cause events like the breaking of the window. And if you kind of generalize enough, then you're going to end up with some laws of nature. Something like classical mechanics explaining why the throwing of the stone caused the breaking of the window. Or at least the laws of nature will come into the explanatory story you tell about why the throwing of the stone caused the breaking of the window. And then there are these cases of dependence, like in set theory, where it seems like no laws of nature are relevant. So if you've got the dependence of a set on its members, then there's no law of nature that says when you've got Socrates, you've got to have singleton Socrates. What there is something like a principle of set theory. So maybe the principle of set theory is like something like a law of set theory. It's like playing a kind of law-like role. Maybe the kind of axioms of mathematics or metaphysics could be kind of analogized to laws of nature. But I'm going to assume that we have a good enough pre-theoretic grip on the difference between laws of nature on the one hand and like laws of mathematics and metaphysics on the other, that we can use that understanding to help us understand the distinction between grounding and causation. And you know, there are theories of laws of nature out there. You can be a Humean about them if you like, and I think this account would still work. And the fact that we have various theories of laws of nature, I think perhaps gives us reason to think that we do have a kind of independent, from metaphysics, we do have an independent grip on the notion of a law. But even if you don't like any of that metaphysics literature on laws, I think that it's a notion that is kind of in good standing in physics as well. I don't think it's a philosopher's invention, the notion of a law of nature. So with luck, you understand this notion well enough to follow me in using it to distinguish grounding and causation. And I've just given this gloss here that's kind of, again, leaning heavily on the word characterize. But roughly speaking, laws of nature characterize how a thing contingently behaves, whereas constitutive principles, metaphysical principles, characterize what it is to be that thing. What a thing is versus what a thing does is a way Eleanor put it yesterday. But I think you can, I can reuse that characterization here. So hopefully we have a grip on that distinction. So how can we go about applying all of this stuff to quantum gravity? So just in kind of toy picture of loop quantum gravity, where what's going on at the fundamental level is some kind of quantum superposition of spin networks, spin foams, then what you have is some fundamental reality which is non-spatiotemporal, and some non-fundamental reality which is spatiotemporal. Don't worry, I'm not going to use these ugly acronyms any longer, but I just wanted to fit it on the slide with it. So then the question is, how is this kind of dependence mediated? What kind of principles are going to help us explain why it is that, given that we've got the fundamental non-spatiotemporal reality, we get the non-fundamental spatiotemporal reality? Like, what can we say to make that less mysterious? Well, I take the kind of basic principle of the kind of one of the key underlying metaphysical posits of loop quantum gravity to say all you need is a suitable, fill in your blank for what suitable means here, superposition of spin foams, then a space-time exists of the kind that can be approximately represented by a model of GR. So I take it that, amongst other things, that's what somebody doing something like loop quantum gravity would say when they're trying to explain their theory to somebody that's never heard of it before. That's what they're in the business of doing, of kind of fleshing in all the details of a schema like that. So one naive thought you might have, I think kind of naive in the kind of first thought, but also in the kind of faulty thought, would be that because this is the kind of thing that physicists end up positing, and if all goes well, kind of discovering to be true, it's therefore a law of nature, because that's what physicists do, right? They discover laws of nature. Well, they do discover laws of nature, but I think they also discover constitutive principles. So kind of science has a long and glorious history of discovering what we now think of as principles of metaphysics. So principles that tell us what heat is, collective molecular motion. It's not a fluid, it is collective molecular motion. Principles that have told us kind of what lightning is. Topical. It's not like the anger of the gods, it's kind of electrical, like large-scale electrical discharge from clouds. Like classic philosopher's example, what is water? H2O. That's something we had to do science to find out, but it looks like a constitutive principle. It tells us what it is to be water. So if I'm right, these are cases where we did like hard empirical work to discover a constitutive principle. And if that's right, then we can't automatically assume that just because some principle has been discovered by physics that it is a law of nature. It could also be a constitutive principle of that kind. So then the question is this principle, LQGP, a law of nature or a constitutive principle? So fitting in with the natural thought that I started with, that the dependence of emergent spacetime on the underlying non-spatiotemporal fundamental reality is grounding, the natural thought via the mediation principle would be that this is a constitutive principle. You might think, well, it just kind of tells us what spacetime is, tells us what it is to be spacetime. You might add, it tells us what it is to be spacetime in loop quantum gravity, and I think to be X in a theory is a very slippery and dangerous locution, and the slipperiness can be successfully sorted out by the kind of functionalism that Eleanor likes, and I'll come to shortly. But just kind of drop that rider for the moment. Suppose that that principle tells us about what spacetime is, what it is to be spacetime. So if you kind of came to believe that some kind of loop quantum gravity theory was true, and you thought it was kind of correctly represented by that general schema, then you might well say, well, I found out what space-time is. I found out what it is to be space-time, and it is to emerge from the fundamental reality via that sort of principle. But now the tension with kind of orthodox metaphysics comes in. And I don't see many orthodox metaphysicians in the room, so maybe you won't care all too much about this. But I think it'd be an interesting result if we ended up modifying orthodox metaphysics as a result of considering these sorts of questions. And the two kind of orthodox bits of metaphysics that I'm going to point to are a claim about metaphysical possibility. Like, other kinds of space-time theories describe genuine metaphysical possibilities. No. The universe really could have been Newtonian. There really is a genuine possible world which is correctly described by Newtonian mechanics, for example. Maybe if you think Newtonian mechanics is, for some reason, inconsistent, to do with, like, the impossibility of point particles, something like that, or the kind of inconsistency of rigid bodies in Newtonian theory. Put in a different theory that you do think is internally consistent in here. All that matters for the argument to work is that some theory that describes space-time, but that is not an emergent space-time theory like loop quantum gravity, should be metaphysically possible. So the basic, what you need is space-time could have been fundamental in some way or another. And then there's this other principle, which is very orthodox in metaphysics, which is that the constitution of a thing is non-contingent. So I connect this up to, like, Kripke's famous principle, the necessity of constitution. If this table is made of wood, then necessarily it's made of wood. If there was a table made of ice here, it wouldn't be this table, it would be a different table. I want to say the same thing about space-time. Roughly speaking, this is the argument. If space-time is in fact constituted by kind of an underlying non-spatiotemporal fundamental reality, then it's necessarily constituted by an underlying non-spatiotemporal fundamental reality. So then it's not true that some fundamental space-time is a genuine metaphysical possibility. So you've got these four, each individually plausible, I think, claims, but they can't all be true together. So the puzzle is, which one of these do we drop?
So is it like heat could not possibly be a fluid? Is that the same type of thing?
Yeah, it is. But I think that is something that we've kind of reconciled ourselves to. Maybe at one time we believed it was like an open epistemic possibility for us that heat be a fluid. But it is not now and was never a genuine metaphysical possibility. We just didn't know that at the time. Maybe this is where you want to push back, but let's just keep going. In metaphysics, this is orthodox, I think. So one way of resisting this is, or was just alluded to, we could give up the principle 2 that says how a thing is constituted is non-contingent. So that would be unorthodox within metaphysics. Maybe we have some independent reason to give that up. Fine. If you want to give up 2, then you can kind of avoid all the troubles that I'm talking about here and that I'm going to go on to explore. You might be a functionalist in disguise if you do that, but wait and see until we've talked about functionalism. The other move is to give up the possibility of a world with fundamental space-time in it. You might reason, well, just like heat, back then, poor Newton, he was deluded. He thought that it was metaphysically possible for space-time to be fundamental. So he thought that the theory that he was considering was like a genuine metaphysical possibility, described some genuinely metaphysically possible world, but he was wrong. It was merely an epistemic possibility back then. So if you have independent reasons for rejecting the possibility of a world with fundamental space-time, again, it doesn't have to be Newtonian, I'm just using it as a placeholder. If you have some independent reason to reject this kind of general inference that if I can conceive of a possibility, if it seems like it's coherent on kind of reflection, then it's a genuine possibility. Again, you don't need to be worried by this argument. But again, it's orthodox within metaphysics that kind of coherent scenarios that you can describe without inconsistency or absurdity, kind of the default assumption has got to be that they correspond to a genuine possibility. So I'll just kind of flag my own view. I don't like the inference from conceivability to possibility. I have a beautiful account of modality, fits wonderfully well with quantum gravity, I think, according to which quantum mechanics tells us what is and is not genuinely possible. So quantum mechanics is a theory of modality of the type that Lewis was trying to develop. This actually, I think, kind of fits quite nicely with the kind of picture that Tiziano was describing. Maybe you have to, if you're not trying to recover Lewis's modal realism, but trying to recover like a modal realism that can do the same work as Lewis's theory, or some of the same work, then you can just take Everettian quantum mechanics and the plurality of quantum worlds it describes as giving you the whole space of genuine possibilities. So I like that view. I'm happy to talk about it for hours later. And that gives you a justification for rejecting the inference from conceivability to possibility. But without such an independent justification, I think it would be ad hoc to reject it just once you notice that there's a problem with emergent spacetime in quantum gravity. One thing that you might try and say is, well, you know, metaphysics is something that we shouldn't have a lot of confidence in. You know, metaphysicians are foolish and they use bad arguments and unreliable sources of evidence. So we just should kind of ignore what they say. And if it turns out that their principle is in tension with something we want to say about emergent space-time, so much the worse for their principle. I don't really think this is the right place to go modifying metaphysics. Partly because it would involve saying that indirectly loop quantum gravity is telling us about what constitution is like or what the nature of modality is like. It just doesn't seem to be the right kind of thing to do that. Or at least the kind of gravity part of it doesn't seem the right kind of thing to do about it. And we also don't get any kind of reason immediately as to why we thought these principles were true, why we thought they were plausible if they're false. And basically they just look like ad hoc moves. So I'm going to kind of hold fixed for now, for the sake of argument, principles 2 and 3, even though I'm happy to give up 3 myself. So supposing we hold fixed 2 and 3, we can then make this kind of argument. So if it is the case that loop quantum gravity is something like it is correct, and space-time emerges, and that emergence is mediated by something like the loop quantum gravity principle I specified, and if how a thing is constituted is a non-contingent feature of it, and if a fundamental space-time is possible, then because in a fundamental space-time L3GP would be false, that means it can't be a constitutive principle because those things are necessary. And then, if it's not a constitutive principle, what else could it be but a law of nature? If it's a law of nature, then emergence is mediated by a law of nature, so space-time gets caused. That's the kind of argument you can run for emergence of space-time in quantum gravity being causal instead of grounding. And that's the kind of unwelcome conclusion we didn't want. Maybe we can live with it. I mean, people do, in metaphysics, quite often float this kind of possibility of causal emergence. Maybe this is just a case of causal emergence. I would maybe be happy with that conclusion. But there are ways of avoiding it that don't involve the kind of nuclear options of dumping 2 or 3. And I think functionalism, of the kind that Eleanor was describing, gives us an escape route here. So given that she described in detail the way functionalism works, I can just be very brief. Functionalism says kind of to be a certain thing is to behave in a certain way. Examples, functionalism about the mind, quite a popular theory of the mind. Functionalism about life, I think, is totally orthodox. If you go and look in any biology textbook, you'll get a definition of life in terms of like a whole cluster of properties, but those properties are all functional properties that can be multiply realized. Actually, some of them say to consist of cells is part of the definition of life, but I think that's just a bad definition. But we can argue about that later. It at least, the account of life given in most texts at least includes some functional criteria. So if you're a functionalist, then you distinguish the role and the realizer. The role is the function, and the realizer is the thing that functions, the thing that plays the role. So functioning about space-time of the kind that Eleanor likes is, broadly speaking, the view that to be space-time is to behave like space-time. So what is it to behave like space-time? Well, Eleanor's answer, which I find very plausible, kind of derives from the picture of space-time that Harvey Brown has defended, is to link space-time to inertial frames. It's a quote from a still sadly unpublished manuscript about this. It needs to be published. But the point for our purposes is just that what space-time functionalism allows for is multiple realizability of space-time. In principle, different things could play the space-time role in different possible worlds. And so in one possible world, the realizer of the space-time role could be this fundamental entity. In another world, the realizer of that role could be something non-fundamental, something that is constituted by something fundamental, or kind of indirectly given rise to by something fundamental. So what this allows us to do is to reject either one or two. There's a kind of bit of a risk of equivocation here when you've got functionalism in, because you can it's easy to muddle up roles and realizers. But suppose you're thinking about the realizer in particular, then principle 2 is false. It's just not true that it's non-contingent what thing realizes the space-time role. It's not on the orthodox view. But if you focus on the role, then instead we can reject one. It's not that that principle from Luke quantum gravity is mediating the kind of dependence of the existence of space-time on the kind of level below. Rather, what's mediating it is a functional constitutive principle, which is just a constitutive principle that is the kind of thing a functionalist would say. So where a normal constitutive principle, a non-functional one might be water is H2O, a functional constitutive principle would say to be a certain thing is to play a certain role. So the kind of thing that you might want to slot in the role of as a functional constitutive principle, if you want to account for the nature of space-time from a functionalist perspective, would be to say something like this. To be space-time is to play the role of inertial structure with respect to symmetries of the underlying dynamical theory. So anything can be space-time as long as it fits that description, as long as it plays that role. So now the dependency of space-time, the existence of space-time on the kind of immediately below level is a functional dependence mediated by a functional constitutive principle. So because we have inertial structure in a given possible world, we have space-time in that possible world. And the principle that mediates that is this FCP itself. That FCP is what explains why, when you have an inertial structure, you have space-time. So that dependence gets to count as grounding by the mediation criterion that I described earlier. But that's not the whole story. So I want to say that overall the story is the kind of story that Antonio described, a kind of hybrid story that has grounding involved and causation involved. Because I think the argument that I presented for emergence of space-time being causal can be reproduced kind of at the next level down. So how is it that we get from the kind of existence of some superposed spin networks to the emergent inertial structure? Well, I think you need to bring in the fundamental laws of nature there to help explain that. And so that is then going to count as causation. So the overall dependence is going to involve a causal step and a grounding step. And kind of, I guess what I'm offering at this stage is just that because there's some grounding involved, that might be enough to do justice to your intuition that emergence of space-time is grounding. But I don't expect people to be entirely happy with that, really. So some of the reasons for rejecting that sort of picture, I think, are not great reasons. The laws of nature are definitely relevant to the emergence of getting inertial structure out of the fundamental reality. Recall that inertial structure has this close tie to the symmetries of the underlying dynamics. So if you had kind of totally crazy dynamics with not enough symmetries, you wouldn't get inertial structure at all. You'd get a world without inertial structure, and then accordingly you'd get a world without space-time. But because the laws of nature, their symmetries, are helping explain why you get inertial structure out of the fundamental reality, it's not surprising then that this is going to count as causation, because those laws could have been different, in which case you wouldn't have had inertial structure, even with a fundamental reality of kind of exactly the same kind. So I think it's not so implausible that that be causation. But if you really don't like that conclusion, you can kind of push it for another level further down. You can say that inertial structure is itself the kind of thing that can be functionally realized. I think Eleanor likes that view about inertial structure. I think it's kind of actually a kind of plausible view. But you can't get rid of the, you can't keep pushing it down forever unless you kind of have kind of an infinitely many layered reality. And even then, I'm not sure it would work. The argument is going to end up recurring as long as there is some kind of contingency somewhere along the way in the relation between the fundamental reality, what it's like, and how it behaves. So as long as you've got some contingent fundamental laws governing the fundamental reality, as long as the laws of nature, the fundamental laws of nature are contingent, there's got to be a causal step somewhere along the line. So it can't be pure grounding. It's got to be a hybrid with at least some causal ingredient in there. And kind of, I'm worried about that. Recall again, because I don't think the fundamental laws of nature are contingent. So if I wanted to, I could say this is actually grounding all the way down. Or at least we'd have to kind of fall back on further considerations to help classify these principles, because the kind of argument from the contingency of the laws and the possibility of other space-time theories wouldn't get the right result. But for anybody that thinks the fundamental laws of nature are contingent and the world with fundamental space-time is possible, I think anyone like that is going to have to admit that there's a causal stage somewhere along the line from the fundamental reality to the existence of emergent space-time. Okay, pretty much out of time. So I'll just leave this, well, I won't leave the summary out because there's some references, but here's what I've said. Nice natural way of thinking that we can distinguish causation from grounding in terms of time. Doesn't work in quantum gravity. Actually, it doesn't work for more general reasons either. Once we move to a different and better way of distinguishing grounding and causation, we run into some trouble with emergent spacetime. It looks like emergent spacetime gets caused. If we want to avoid that, then functionalism provides a way out that avoids having to modify our fundamental metaphysics. And if we take that functionalist way out, we get something like this kind of hybrid picture where emergent spacetime depends on the fundamental reality via a combination of causal and grounding steps. And insofar as you think that that's like a nice coherent picture, then that should boost your confidence that emergent spacetime itself is not this crazy incoherent notion. And if you were tied to emergent spacetime being grounding, and you were tied to these metaphysical presuppositions, I guess you might in principle have taken that as a reason to reject emergent spacetime. And I think that would be bad reasoning. We shouldn't just reject emergent spacetime on these sorts of a priori grounds. So that's one kind of way in which we can get a coherent picture of emergent space-time. Maybe there are others. It'd be interesting to hear what people think.
Thank you. We have 20 minutes for discussion. Yes, please.
Yeah, thank you. I have two questions. First, about your claim that you would need to change some fundamental metaphysical principles in order to avoid the conclusion that we have causation. I didn't quite see that, because one thing is the way you define the constitutive principle, and the other is the question of what you use as a criterion for distinguishing between grounding and causation. So wouldn't it be sufficient just to change that, which wouldn't amount to a very deep fundamental metaphysical shift? That's the first question. And the second, about the last point, where you argued that there may also be causation involved because the dynamics might decide whether or not this underlying structure is of a kind that actually amounts to space-time. Couldn't one say that you're discussing two different levels here? So there is the causation going on at the fundamental level. The dynamics can be entirely described at this fundamental level, spin forms or whatever. And then there is grounding from the specific outcome of which amounts to specific spin form structure that actually represents space-time. So the grounding would be there, and the causation would be at the fundamental level. That's the second question.
Okay. I should go over here. So, firstly, yes, if you have a better alternative to the distinct mediation test for distinguishing grounding and causation that can handle emergent space-time nicely, that can avoid the kind of counterexamples I was worried about, and that it's kind of well motivated on independent grounds, great, use that. I'd like to know exactly what that might be. As I said, I think there's some problems with the most natural ways of doing it in terms of time, and in this manuscript, which you can email me if you want a copy of, I go through a number of other potential criteria and find problems with them all. So I just don't think there is such a good principle around. But if there was, then obviously that would be an easier way to get out of the argument than the ones that I described of giving up those two or three. There was a second half to the first point. What was the second half of the first point?
Maybe just a short question on that. Wouldn't it be sufficient to say that those are, you don't have actual constituent principles, but you have principles within the framework of a theory, something like that?
Yeah. So I guess
so this constitutes that in the context, within the framework of that theory.
Yeah. So this relates to what I said about in Newtonian mechanics being a kind of quite slippery rider to add on to a metaphysical claim you make. Metaphysics doesn't seem like something that is like theory relative to me. It seems like there should be like the truth about metaphysics. Different theories might disagree about what the truth about metaphysics is, but it's not like there's one truth about metaphysics according to this theory and an equally legitimate theory that, like, some different fact truths about metaphysics according to that theory. If the different theories have different metaphysical consequences, at most one of them can be right about metaphysics. So, just on the second point, the way I'm thinking about it, the fundamental reality is just a matter of thinking again, distinguishing sharply between kind of what a thing is and what a thing does. I was assuming that whatever the fundamental reality is like in loop quantum gravity, it's going to be compatible with, it's not going to kind of come with all of the laws that govern it kind of built in already automatically, there's still a distinction that can be made between what exists and what characterizes those things. If there's no distinction at all between those things, then I think you are giving up the contingency of laws of nature. The most you've got then is that there could have been different things that necessarily behave the way they do. But a given thing necessarily does what it does. And that is, I mean, dispositional essentialists say a thing like that. It's not unknown, but it is controversial within metaphysics. I should have said that you don't have to be as strong a kind of anti-rationalist as I am about conceivability and possibility to get this result. You can be the kind of weaker, like I think that like the fundamental laws of quantum mechanics are true at all the possible worlds there are, not just all the possible worlds that involve wave functions. But someone like Alexander Bird is going to say, if there are wave functions, then quantum mechanics is necessarily true of them, but there might not have been wave functions, there might have been something else instead. So it depends whether you're prepared to build the laws that characterize the behavior of a system into the nature of the system or not. If you are, then I agree that gives you a way out of the argument.
Please.
So, this isn't a sort of major critical point, but I started to wonder if there's an equivocation on the notion of the constitutive principle.
Maybe there is.
It started to make me worry about whether the same thing was going on. Just in the sense that, I mean, when I sort of, I mean, I suppose I do think of the functional analysis as giving something like a constitutive principle in that it tells you that to behave in certain ways is constitutive of the concept of space-time or something like that. But of course, constitution, in the metaphysical sense, in the sense of what makes up a physical entity, is presumably something completely different. And I started to worry that, you know, when you had one constitutive principle, you were talking about what would constitute a. So there's supposed to be sort of notion of ground going on in both their contexts, where you're wondering about whether spin phones make up a space-time, and another where we're talking about what's constituted from the concept of space-time. Those two things, apart from the coincidence of the word constitution occurring in both, seem unrelated. I don't know if that really affects anything here. It's just
I mean, that would be a worry, at least for the application of functionalism as a kind of for the thought that functionalism engages successfully was the kind of worries that I was raising. I hope there's no equivocation. I guess what I see is, the way I see it is that constitutive principles that kind of say what a thing is in terms of what it's made of, and constitutive principles that say what a thing is in terms of what it does, really are kind of comparable. They're rivals to one another. So I'm thinking of, like, just take a kind of cheesy case like water. There's like the non-functional constitutive principle that says water is H2O, and then there's this kind of like internalist friendly functionalist constitutive principle that says water is like whatever is like drinkable and flows in rivers and falls from the sky and is clear and liquid and has these like melting and boiling points and so on. And I see those as rivals to one another. And, you know, kind of the kind of Kripke-Putnam kind of triumph in metaphysics in like the 70s, I see as the triumph of the constitutive account of water over the functionalist account of water. So at most, the functionalists, the functional claims kind of fix the reference rather than doing constitution. So I mean, there are two different sorts of things here. It's not like functional constitutive principles are just the same things as non-functional constitutive principles, but I do see them as direct rivals. Yeah, I think that's what I meant to say.
Richard, please.
Yeah, I don't remember whether you were there at the Oxford. I don't remember whether you were there at the Oxford conference where I gave a talk entitled "The Independent Emergence of Space-Time."
I don't recall that.
Okay, I gave that talk because I wanted to question the status of a number of your moving parts here. First of all, the part which assumes that we have a fundamental basis, the LQGP principle, was supposed to connect a suitable superposition spin formed to an approximately generalistic space-time. But if you don't think that a suitable position that spin forms is in the business of ontology in the first place, then that's not going to get you what you want. That's one moving part that I want to question. Another moving part is the notion of the law of nature. Now, philosophers love to go on and on about laws of nature and have various rival accounts of them and have disputes amongst themselves. But you correctly pointed out that scientists talk about these things too, and they take them pretty seriously. My earlier diagnosis of why scientists did that is that they're basically paying homage to Newton. They say, we're in the same business of Newton, that's why we want to come up with the fundamental laws of nature. Yeah. But actually, the notion of a law of nature does play an important role in science. But typically, I think now, that is not a role that's going to be necessarily connected with sort of fundamentality or truth or anything like that. It's itself a more sort of functional concept. So those are reasons to question the moving parts. But on the other hand, I'm sympathetic to the idea that space-time emerges in some sense from something. It's just that we just have no idea, despite the existing sort of attempts to come up with a quantum theory of gravity as to what that might be.
Right.
We have to question categories like, will it contain laws of nature?
Yeah.
Will it contain, as a quantum theory, any kind of representational claims? That's what worries me, but I'm sympathetic to retrieving space-time somehow, in some sense.
Nice. Yeah. I guess there's enough, I have enough knee-jerk realism in my philosophical upbringing that I wasn't I hadn't even considered the kind of possibilities where you kind of go down below a certain level of explanation and you're not in the business of ontology anymore. I guess I was thinking that kind of if you can ever explain anything in terms of a lower level, that kind of explanation would be unsuccessful or unconvincing or vacuous. There wasn't some ontological reality there to kind of make it kind of set things going, make it work. But I mean, that's just I'm just kind of expressing instinctive realism there. On the notion of law of nature is interesting here because I think kind of Humean accounts of laws of nature would work here. So it's not like the notion of my idea was that even though the laws of nature are kind of crucial in kind of explaining the various kinds of connections between the various kinds of levels and ingredients of reality, I'm kind of using them. I don't think they need to be fundamental themselves in order to do that work. And I was hoping that like a very deflationary Humean theory could still kind of classify things in the right sort of way. And so you would get a kind of, so it's not like you have to be anti-Humean for my sort of picture to go through. You don't have to be kind of that metaphysically realist. But yeah, I mean, one of the things I like about these sorts of audiences is that everybody is much more open-minded about the kind of metaphysics that they're prepared to take seriously than the metaphysicians that I normally talk to, who are much more, you'd think that they were professionally inclined to explore a variety of metaphysical hypotheses, but actually there's kind of a social kind of orthodoxy that kind of keeps people on the straight and narrow. So people like me that think the fundamental laws of nature are non-contingent, we're heretics, and I kind of have to keep that kind of quiet a lot of the time. And so when I kind of, I guess it's, my instinct is when I write a talk like this, I kind of take for granted those principles, and then I come and talk to philosophers of physics, and people are much more prepared to give and take on those principles. And I think physicists are in the same boat as well. And yeah, my instincts go that way. So just kind of put a prefix in front of a lot of these arguments. Given assumptions that are orthodox within metaphysics, these sorts of concerns arise and can be solved in these sorts of ways, but maybe the response to them is to reject those sorts of, because I would like to have some independent reason for rejecting those rather than just they cause problems here.
Sure.
But I think it sounds like you do have some independent reasons for rejecting those kinds of principles, and I think I have my own as well, though I suspect they're not the same kinds of reasons.
Right, yeah, and I think I want to reject more than the moment you're willing to reject. For example, Humean accounts of laws of nature at least assume that they're true.
Yeah. No, fair enough. It does certainly seem to be the case that there are things that scientists will call laws that do tolerate exceptions. And I guess I'd have to say, though, that that's kind of loose talk. Though actually, I have a chapter on laws of nature in my book manuscript that allows them to do that, but that's only about the non-fundamental laws. I think the fundamental laws are in a different category and they don't tolerate exceptions. But we can talk about this.
Thank you.
Tushar, and then Chris, and then John.
Thanks for the great talk, Alan. I just have a question. So this sort of came up in passing towards the end of your talk. This might be a bit of a tangent, but I'm still going to ask it. You can sort of evade it. We can talk later. But sort of two small questions. One is you mentioned that on your view of possible worlds as being the branches of the arithmetic multiverse, you don't have space-time. You don't have a possible world in which space-time is fundamental. Was that right?
That's the idea, yeah.
But there's if the branching structure is sort of dynamically economics induced and emergent from a wave function, which is itself defined on not ordinary space but configuration space, or if you instead go for something like a Timpson and Wallace style space-time state realism, then it seems like there is an interpretation on which your possible worlds do have a fundamental space-time. Sorry, can I just add the second part of the question so that I can move the mic up? And as a sort of related to that, on your view of modality, are there worlds in which are there distinct possible worlds in which string theory and loop quantum gravity are true, but give rise to the same wave function?
I'm really glad you asked. My view is even more extreme than I might have led people to believe in this talk. It's not just that quantum mechanics is necessarily true and the range of possibilities are like the different quantum theories out there, including some with fundamental spacetime and some without. The view is whichever quantum theory is actually true, whether that be string theory or a version of loop quantum gravity or something like that, that specific theory is necessarily true. So only the worlds that are kind of Everett branches with respect to that theory are genuine possibilities. My hope is that will still get you a lot of variety and potentially give you responses to kind of fine-tuning kind of considerations as well, by there being a lot of differences amongst the different branches at the non-fundamental level, even if they're all alike at the fundamental level. But that's a kind of an open empirical question, and if it turns out that we come up with a great theory which has seems to be in other ways a great candidate for the final theory, except it has all of these constants built in that look totally arbitrary, that would be kind of bad news for the view. I'm hoping that we come up with a fundamental quantum theory that will be able to account for all the things that we have really good reason to believe are genuine possibilities, such that it doesn't look kind of arbitrary that we've got some in and some out. But yeah, the ultimate thought is that whichever is the true underlying quantum theory, that thing will characterize the space of objective possibility.
Towards the end, you suggested that we may avoid the conclusion that there's a mixed form of dependence, grounding, and causation involved here by functionalizing sort of the next level. Functionalism about inertial structure, which you then rejected. And that's, of course, a general feature of functionalism, I think. Often you can go on and functionalize more, but really that seems not to be quite right unless you terminate it somewhere. And then as soon as you terminate it, I guess the problem will then follow again. However, there seems to be another way to resist the conclusion that we haven't considered, and that is by rejecting your diagnostic test. I could just say, oh, we just got that wrong. Here's another test which is superior, and it's its superiority shows itself, among other things, in that it classifies this case unambiguously as a case of grounding and not causation.
Do you have such a test to suggest?
No.
Well, let me know when you come up with one. No, fair enough. No, that is the kind of, I actually didn't want to reject functions about inertial structure. I think functions about inertial structure probably is correct. Really what I was trying to say was that the argument will recur at some stage unless you're functionalist all the way down. So if you're a kind of ontic structural realist that believes that like all there is structure and there's infinitely many layers of structure and you have some reason, I don't know what it could be, to believe that there will never be a non-structural layer no matter how far down you go, then maybe it's grounding all the way down. I think such a view probably actually is going to end up committed to the non-contingency of the fundamental laws anyway, but I'm not sure about that. Certainly, kind of structuralists do often end up being less wedded to contingency than the non-structuralists are. But assuming that the functionalism terminates somewhere and doesn't keep going all the way down, that was where you were going to get the causal layer. And I'm really open to better tests. There's something that I find intuitively satisfying about the role that the laws of nature are playing in. It just seems right that causation is dependence that is mediated by dynamical laws. Maybe dynamical laws, in turn, we only have a grip on via like the kind of laws that mediate causation. I'm not saying that that's a kind of I'm not certain that we have an independent grip on the relevant notion of laws, but maybe even then, maybe that would still be okay. They kind of form a kind of circle of concepts. And I've given this kind of talk a few places now, and nobody has come up with a criterion that I found very convincing, but maybe it's still to be found.
John, please.
Could you say something more about the difference between temperature and Newtonian spacetime? Because it looks like, to me, the same reasons that I would think temperature is necessarily meaning like I mentioned, and that's not really like a problem, even though it might first sound like one, are going to apply in the Newtonian spacetime case. Like, so with temperature, I mean, like, you know, whatever it is out there that is causing this sensation, and I mean to fix my reference by doing that, and so, yes, so identity, etc.
Yep.
Similar to spacetime. By spacetime, I mean, like, you know, whatever this stuff is, and then Newton had a theory about what this was, and he was wrong. And so there's a world out there that, like, is the kind that Newton described. It's just that's not spacetime. It's like between spacetime or something.
Right. So the point's very well taken. If you're prepared to say that Newtonian spacetime isn't, you know, suppose loop quantum gravity is in fact true, and spacetime, the thing, spacetime that we know and love, that very entity is necessarily constituted by spin foams on the kind of way that I described. You might still say, well, a Newtonian world is possible, it doesn't contain spacetime. It contains spacetime star or something like that. So it's not like these are different theories about one thing, spacetime, they're different theories about different things. So I guess it seems like those theories are trying to describe the same thing to me. I mean, you'll see that I built that into the principle here. I did this kind of carefully. It's not just that like a space-time exists. I said like space-time itself, that thing exists. And then the thought is that space-time would be one and the same thing in these different worlds, albeit governed by different laws. That would be the kind of... I think that is kind of the most natural view. But it is in the same way that I said that what, like, the locution, what space-time is in this theory or in that theory, the slippery one. When we talk about a space-time, is also a kind of slippery one as well, like a Newtonian space-time, a general relativistic space-time. That locution is kind of, I mean, you might think that's already got tacit functionalism built in, like these are different ways of being, like having the property of being such a thing as a being a space-time. But so this does rely on the thought that they're the thing space-time, and we can talk about what that thing would be like in different possibilities. So, yeah, I guess what the kind of considered response there is going to be, yes, you can say we have space-time in this one world and space-time star in another world. Well, what makes them both the kind of thing that we can use the word space-time to describe? Well, they both play the same functional role. So I think you're going to end up getting back on board the functionalism bus if you push that line in a sensible way.
Okay, I think it's time for dinner.